Hello everyone, myself I am Saranya, working as an assistant professor in the Department of AIML in MLR Institute of Technology. Today I am going to discuss about the topic of substitution techniques in the cryptography. So coming to the first slide, we need to see what is substitution techniques and types of the substitution techniques and what is the Caesar cipher, Playfair cipher. These are the two types of the substitution techniques in the cryptography. The substitution techniques are two types. One is Caesar cipher and another one is Playfair cipher. First one, we need to know what is meant by substitution techniques. So basically the substitution technique is a classical encryption process. So where the characters or any initial images was restored by other characters or numbers or any symbols. So it is nothing but an classical encryption process, which is nothing but an other characters or any other numbers or any other symbols. It can be present in the initial messages. So it also contains the plain text. It is nothing but an original message which contains the string of bits. So it can be restore any bits of patterns in the plain text process and it will get the output of the ciphertext process. The next two types of substitution techniques already we have seen in the first slide. So there are two types. One is Caesar cipher and the second one is Playfair cipher. These both are the encryption techniques in the classical process of substitution techniques, which are enable to the plain text and also output to the ciphertext. So we are taking one example of plain text and how it will get the output of ciphertext. Then first one is Caesar cipher. So the Caesar cipher is also the one of the technique of the substitution technique and it is also type of ciphers. So the Caesar cipher is nothing but one of the most simplest and oldest methods of the encryption messages, and it also involves basically shifting the letters of the alphabet and also the number of places. For example, it is a shift of 3 letters. So however we are taking the any number of, for example, here they are taking the 3, we can take as an 4, 5 and 6. Based on the sender and the receiver of the question will be there of any 3 format or 4 format, 5 or 6 formats. For example, with the shift of 3, the letter A becomes D. So A after B, C, D. What is the third place? The third place is the D. So that's why A becomes the D and also B becomes E. Like that, how many alphabets or any numbers will be there? We need to shift with the place of 3. And also this encryption can be represented using the modular arithmetic format by transforming the any letters into numbers with the scheme of A equals to 0 up to Z equals to 25. So with the initial stage of 0 or 1. For example, I can take A is equals to 1 or A equals to 0. With these numbers, we can, for example, A is equals to 0 means Z is equals to will be 25. For example, A equals to 1, the Z will be numbering of 26. Wherever we are going to start with the initial stage of the letter A equals to 0, the Z will becomes the 25 number, and for example A equals to 1 means the Z equals to 26. Obviously the encryption of a letter will be shift n can be mathematically represented as, for example, if the shift is 3, the letter A would be replaced by D, B would become E and C would become F. Like that we need to solve up to Z of the letter. So if the alphabet is wrapped again after Z, it starts again from the A, letter A. If for example alphabet is wrapped again after Z, it's going to start again after that A. So here is one of the example how to use the Caesar cipher to encrypt the message with the word of hello. So I am taking here the word of hello with the shift of 3. Here I am taking the 3. So let us assume with the hello of 3. So these are all plain text. So whatever we are getting the taking of the encryption process of the hello, it is an plain text process. So what we are getting after the final output, it is an ciphertext. So adding of H. See here, H. Already H is in the place of number 7. So by doing of shift 3 places, what would become? 1, 2, 3 means letter of K. So already we got the letter of K, for example. The next, what is the letter of E? The letter of E would become F, G and H. So already with the places of, with the count of E, 1, 2, 3 means we are getting the value of H. So K after we got the H for the E input. The next one with the letter of L. L is also L. By doing the places of 3. 1, 2, 3 means we getting the letter of O. Letter O. Then we got the third letter also. The next for is also L. So L we have seen in the previous also, we can written here as O. The next, what is the letter of next one? O. O is becomes to next of 1, 2, 3 means with the letter of R. So with the letter of R, I got the ciphertext process. This is the Caesar cipher. So whatever we are going to take as the input of any letter or any alphabets or any symbols with the place of 3, with the shift of 3, 4, 5, 6. Based on the question, we need to calculate by seeing this table format and we can calculate the ciphertext. Next, for example, I have taken here attack attons. So I am using here the word of shift 4. What will get with the shift 4? For example, I took the letter of A, first one. What is the A? With the start of 0. So I got the 1, 2, 3, 4 means the letter E. Like that, we need to do up to the E part of the with the shift 4 places means we need to start with the starting letter and we need to count up to 4 places means 4 places, 5 means 5 or 6 means 6. How many? The number will be based upon the shift process. That is the ciphertext of the output. The next second type is playfire cipher. So basically this playfire cipher is also consist of basically 2 steps. One is grid by grid format means 5 by 5 grid of any alphabets that can be acts as the key for encrypting the plain text process. So it also consists the generating key square with the grid of 5 by 5 acts as a key for the encrypting of the plain text process. And also each of the 25 alphabets should be an INQ format and also one of the alphabet is omitted from the table. Means it can be hold only 25 alphabets. For example, the plain text contains J, then it is replaced by I. I will show the example in the next slide. And also to encrypt the plain text, it can be split into pair of 2 letters. For example, if there is any odd number of the letters and Z is added to the last letter. So see the example of here plain text, for example, instruments. So starting stage we have taken the plain text of instrument process. We need to split into 2 letters. Already I have told you that here 2 letters we have splitting them. So 2 letters which is going to in, ST, RU, ME and T. So already here S was going to the remain of the 1 letter. So by using this 1 letter, we can add any of the bogus letter, that is X, Y, Z. For example, I have taken here Z is the bogus letter. Means we need to add the letter Z for the S. That's why I have written here the SZ process. So after this splitting process, each process will got the 2 letters. For example, means how we need to format or how we need to calculate and how we will get the any number of the cipher by using the play file. We need to see the output. Means first we need to know the process of the play file. This is the starting stage of the first one. If the both letters are in the same column, for example, it is in the 4 letters will be in same column, means what we need to do? Take the letter below each one going back to the top if it at the bottom. So here I have taken the word of ME. So obviously you are seeing here the letter of M. M is already there, C is there, E, L and U. These are the column wise I have seen in the letters of M to U. So already here asked the question with the ME process. M will be replaced by next letter and E is going to be related with the next letter. For example, here MU with again one more letter will be added of U, means here U after also will be there any one of the letter. So that's after that we need to get U only after W. But here given only the 2 letters. Means if the both letters are in the same column, we need to take the letter below 1. That is the first one. The next, if the both letters are in the same row, if the letters will be in the same row, then what should we need to do? Take the letter to the right of the each one. Means going back to the leftmost if at the rightmost positions. For example, here already have given the format of S and T. Here also they given the encrypted text also T and L. So the question is S and T. So S and T are in the same row. Then what will get the output of this encrypted text? So the 2 of each one go to the back to the leftmost at the rightmost position. So the answer will be the L. Means S tends to T and T tends to L. Means obviously it returns to the process of the starting stage. So while it is going to be end in the at the end format of the rows, we need to start again from the beginning of the letter. Means for example here P to Q, Q to S, S to T and T to again L. That is the process when the both letters are in the same row. The next, third rule. If neither of above rules are true, then what should we need to do? Form a rectangle with the 2 letters and take the letters on the horizontal opposite corner of the rectangle. Means we need to take the corner of the letters. For example, here the question are N and T. NT means here from the rectangular box there are 2 letters which is in the horizontal opposite corner of their rectangle box. So already here N is there. So what is the solution for the N process? Means N related to the corner of the last position, and what will be in the corner of the position? It becomes to the Q. Means the middle of the letter will goes to the rightmost line of the corner, and rightmost corner will comes to the middle of the horizontal line. That is the output. N becomes will be R, T becomes Q. For example, if there is an D belongs to Y and G will belongs to K, with the 2 letters will be then horizontal opposite corner of the rectangle. That is the third rule. For example, here overall the whatever we have discussed with the previous slides of, this is the first rule, when in the same column and when in the same row and both above rules is true, means what will get the output. So of all combining this 1, 2, 3 rules, we are going to see an example. For example, we already taken the plain text, that is instruments. Instruments we have added the here bogus letter of Z. So after this doing the instruments process of the plain text, what will be then encrypted text? So I becomes G, N becomes A, S becomes T, T becomes L, R becomes M, U becomes Z, M becomes C, E becomes L and N becomes R, T becomes Q, S becomes T, and Z becomes X. So what is the all process of this starting I to X process? So for example, here already we have seen in the previous slides. So we need the letters of the all instruments process. So in the letter, I becomes to the beside of the G process. So N becomes the A process. Means rightmost corner when it is in the same row and when it is in the same column, we need to already we have solved in the previous slide. Like that, we need to take off the instruments. The output will be an I belongs to Z and also the last of Z belongs to X. So whenever it is the both of the previous slides, that is will becomes an beside of the letter, means S becomes to T and X becomes to Z. Like that, when in the corner of the horizontal process, N becomes R and T becomes Q. If it is in the same line, S belongs to T obviously and the D belongs to starting of the letter L. If it is in the same column, M becomes C, E becomes L. Like that, at the corner of R becomes M and U becomes Z. If it is in the same column, M becomes C, E becomes L. Like that, we will get an output process. So in today's session, we have discussed with the substitution techniques and its types, means types of Caesar cipher and Playfair cipher. In the next session, we are going to discuss what is the transportation techniques and how many types of transportation techniques we can see in the next video. Thank you.